Hello everyone, this is Marcus from Shining 3D. In today's webinar, we will talk about the Cap Scanbody and we will also go through some updates for the intraoral scan software. We will begin with a clinical case using the Aoralscan Elite. The Aoralscan Elite is a 2-in-1 system that combines structured light scanning technology and IPG, the intraoral photogrammetry technology. You can see that the doctor is using the Elite to scan post-operative soft tissue. Even with blood interference present after surgery, the Elite is still able to quickly capture edentulous data, thanks to the continuous optimization and upgrades of our software for edentulous scanning. In this immediate loading case, the goal was to chairside 3D print a bridge without tie base, placed directly on the multi-unit abutments. The known limitation of intraoral scanners is their relative inaccuracy for multiple implant positions in full arch implant restorations. Aoralscan Elite uses intraoral photogrammetry technology, completely eliminating interference from mobile soft tissue even in immediate loading cases with open flap surgery. The process identifies only the coded markers without relying on scan body geometry data. The soft tissue processes thousands of photos collectively, achieving global optimization with precision within 5 microns to ensure a perfect fit for the restoration. This slide shows the most updated compatible implant system for Aoralscan Elite. As you can tell from this chart, we now have high-accuracy coded scan body kit A, B, C, D, E, F, and others. More implant systems are being tested for compatibility with continuous updates in progress. Here is an overview of the Elite immediate loading protocol, which collects all digital information of the patient's records needed for designing provisional restoration, starting with the pre-operative occlusion, and the Elite scanner's edentulous scanning workflow easily captures the pre-operative soft tissue 360-degree denture occlusion and automatically completes the alignment, preparing for the transferring of the pre-operative bite relationship into the post-operative restoration design. Then, as mentioned earlier, we perform post-operative soft tissue scanning and use IPG technology to capture implant positions. Finally, we need to align all the data to the same coordination to transform implant positions and orientations into the coordinate system of the soft tissue. We conduct a scanning process for each side of the arch to align them. Blood and saliva as well as mobile soft tissue make the alignment process challenging in immediate loading cases, especially for the mandible, which lacks of features for alignment. This slide shows the comparison between the immediate loading cases and the final restoration cases for the soft tissue and implant position alignment. For the final prosthetic restoration, as you can see from the right side of the video, the accurate alignment of the soft tissue and implant positions can be achieved through just scanning using the intraoral scanner. As you can see in the video on the left side, the data collection for an immediate loading case is influenced by the blood and the mobile soft tissue, which makes the alignment through scanning more challenging, and it will affect the final accuracy. Especially in mandibular cases, the lack of features and the accumulation of blood and saliva make the alignment more challenging. These cases often require manual assistance for alignment. As you can see from the screen recording on the left side, the software failed to do the auto alignment for the alignment between the soft tissue and the implant position. So we provide the manual alignment, which means you can choose 3 dots to align these 2 sets of data together, and it just makes the whole workflow more flexible. And once it's failed to align them automatically, you can always choose manual alignment. And inaccurate alignment can ultimately result in excessive pressure on the gingiva by the restoration. As shown on the image on the right side, the implant position and the abutment position on the soft tissue are not well aligned. To address the challenges in immediate loading cases, we introduced the Cap Scanbody to assist in soft tissue and implant position alignment. The Cap Scanbody is typically placed right after implant surgery and serves as a protective cover during the initial healing phase, helping to prevent hard and soft tissue collapse. The Cap Scanbody features an integrated screw design and hexagonal head, allowing the user to manually mount the Cap Scanbody directly onto the multi-unit abutment, making the process very convenient and quick. On the left side of this slide shows the IPG file captured using Aoralscan Elite. The Elite IPG file provides high-precision implant positions for a passive fit, unaffected by any distortion when scanning soft tissues. The IPG file can be converted into a scan cap library to assist with the soft tissue alignment, or it can be converted into a brand-specific scan body library for the subsequent design. As you can tell from the right side, it is the soft tissue scanned with the Cap Scanbodies on. The soft tissue data provide the surface information necessary for completing the prosthesis design. During the soft tissue scanning process, with sufficient data from all 6 phases of the Cap Scanbody is collected, the software will automatically recognize it successfully and generate the corresponding library data for the subsequent alignment with the implant positions. And it will do a auto alignment if you want to align using the Cap Scanbody. And the implant position data and the Cap Scanbody data will be converted into a digital library data, enabling automatic alignment without the need for an additional scanning process for third-party software for alignment. According to the treatment protocol, the dentist can choose to first capture the implant position or the soft tissue with Cap Scanbodies. In this case, the soft tissue has already been sutured, and the Cap Scanbodies are screwed onto the multi-unit abutments. So soft tissue scanning is performed first. This is a detailed screen recording for scanning workflows with Cap Scanbodies on. As you can see from this step, the dentist can scan the soft tissue with the Cap Scanbodies on, which means the main focus is scanning the soft tissue, but with the Cap Scanbodies installed on the multi-unit abutments. And once the Cap Scanbodies is successfully captured, it will show a number, and you can hear a sound that symbolizes it's successfully captured. And then we can uninstall the Cap Scanbody and install the accuracy code Scanbodies on the multi-unit abutments. And once we start scanning with the accuracy code Scanbodies, it is just the same as the old workflow. So it is using the intraoral photogrammetry technology to collect the implant position with the help of accuracy code Scanbody. And once these 2 sets of data are successfully collected, the software will do a automatically alignment with automatically alignment between the accuracy code Scanbody and the soft tissue data, which means the soft tissue data with Cap Scanbodies on. And we will explain how the whole workflow goes when we get into the detailed information in the following slides. Now, since we had a basic understanding of how the whole Cap Scanbody workflow works, then we can do a comparison between with and without the Cap Scanbody to do the alignment with the accuracy code Scanbody and the soft tissue. And without the Cap Scanbody's help, we can do an alignment as well. It's just like the normal workflow, which means you can do a post soft tissue scan and then do an implant position capture and an alignment of these 2 sets of data once you captured all the necessary information. You scan the Cap Scanbody as well as the soft tissue with the Cap Scanbodies installed on the soft tissue or on the multi-unit abutments. So the mandibular feature deficiency, which means insufficient features reduce stitching accuracy, impact the prosthesis fit. And unstable soft tissues for the immediate loading cases, the blood and the saliva and the unstable soft tissue will lead to stitching failure for the alignment between these 2 sets of data. And a scanning alignment to perform scans on both sides of the arch, manual stitching may be needed if automatic alignment fails, as we already mentioned during the whole webinar. But with the help of the Cap Scanbody, it can increase the efficiency and increase the successful rate and will be fully automatic for the alignment. And this slide shows how the software transformed two sets of data into the same coordinate system to complete the alignment. The implant position and the Cap Scanbody are both converted into a cylinder-shaped library, ensuring the successful rate and the accuracy. And if the automatic alignment fails, manual alignment can be performed as well. So as we already maybe noticed in the screen recording for the Cap Scanbody workflow, a screen recording of the Cap Scanbody workflow, that once we finished scanning the Cap Scanbody, it will number the Cap Scanbody. At the same time, it will convert the Cap Scanbody into a cylinder-shaped library. And since we removed the Cap Scanbody and install the implant, the high-accuracy Cody Scanbody. Once we finish scanning the high-accuracy Cody Scanbody, it will also transfer or convert it into a cylinder-shaped library, just the same as the Cap Scanbody. And then with the same coordinates these two parts may have in common, we can align these two sets of data together with the same shape library. The same with high-accuracy Cody Scanbody. The Cap Scanbody also should be chosen based on the implant that you're using. It is divided into A, B, C, D, E, F, and others categories. And since the Cap Scanbodies will be part of the standard package of the high-accuracy Cody Scanbody kit, so for customers who have already purchased the Elite scanner, we will provide one free set of Cap Scanbodies for each unit. You can contact your reseller for detailed information. For additional purchased Cody Scanbody kit, if the corresponding Cap Scanbody is required, it will need to be purchased separately. Each Elite scanner includes one free set of Cap Scanbodies only. Okay, now we can get into the detailed part of the Cap Scanbody workflow. The first step is the soft tissue scan. Make sure all Cap Scanbodies are fully seated on the multi-unit abutments before scanning the soft tissue. Scanning all surfaces of the Cap Scanbodies to obtain sufficient data, and the software will indicate successful recognition of the Cap Scanbodies. The number of successfully captured scan caps will be displayed in the top right corner. As you can tell from the screen recording on this slide, you can scan the soft tissue with the Cap Scanbodies on and scan all the surfaces of the Cap Scanbody. If it is successfully recognized, you can see the number on the top right corner, and you can also see a virtual cylinder shape library the Cap Scanbody is transferred into. It means it is successfully recognized. It is recommended to successfully capture 3 or more Cap Scanbodies to ensure the accurate alignment for one single arch. To successfully align the post-operative soft tissue and implant position, at least 2 Cap Scanbodies must be scanned and recognized. The accuracy may be affected. So this is how the whole Cap Scanbodies thing works. And this slide shows the auto alignment. The image on the right shows the final alignment result. Despite some discrepancies, these are due to the unavoidable errors in the intraoral scanning of the soft tissue. We can consider this result to be consistently successful. There is no need for concern, and as the precise implant position data captured using the IPG technology will be used in the subsequent design to create the restoration and multi-unit abutment interface, ensuring passive fit. In the subsequent design, the Cap Scanbody data will be cut out from the soft tissue data to design the fitting surface of the restoration. So you can see from the screen recording, this shows the final result of the scanned data and aligned data between the high-accuracy Cody Scanbody and the Cap Scanbodies. That's pretty much all for the Cap Scanbody's part, and in the next part we will get into the updated features for the intraoral scan software. The first part of the updates is the cloud-based integration. It means that the Shiny 3D Dental Cloud now can let the lab site to choose the brand implant scan body data from the dental cloud. For some cases, the dentist may not sure or may not know about the implant the implant scan body system they're using, the exact scan body data they're using, so they can just leave all the scan body or the implant scan body library unchosen and directly sent to the lab, and the lab can do a selection on the cloud side to make sure it is the correct implant data or implant scan body data they choose, and it can avoid some confusion or chosen of some libraries. As you can tell from the screen recording, it is directly on the cloud to do the selection and the conversion. So the second updated features for the software is how to download implant libraries in the future. And we have already mentioned that we will add new implant libraries to the list. And once we add new libraries to the list, the users can directly see the library added to the list on the software side, which means the implant system selection interface that you can see the newly added implant libraries. And the users can directly download the newly updated implant libraries from the software. So it will be more convenient. Last but not least, the final update content for the Aoralscan software is the Aoralscan software on Mac OS. Currently, the Aoralscan 3 and 3 Wireless has Aoralscan software on Mac OS, and you can find the exact version on our downloading page of the Dental Support Center. And the Aoralscan Elite is coming soon. Aoralscan software on macOS is coming soon, and it will be released in the first quarter of 2025. That's all for today's webinar. Thank you all for your attention. I will see you soon.